And we're back here now looking at the Node.js course from zero to mastery structure. I can make a quick recap of sorry. I can make a quick recap of what GraphQL is. So it allows you to build front-end and back-end applications. It's a new query language. That the beauty of this is that it allows you to see how different pieces of data in your server relate each other. So it all starts by describing is the data using a schema, and if you want to query data, you do that using GraphQL queries. So it is much like selecting property on an object, and this is very helpful because since the shape of a GraphQL really match closely what the object we expect from the results, we can predict much more what our object or what our query will return, including is a property field without knowing how the data is stored in the server. So that result is a JSON object with exactly the data that we need. So what are the issue that GraphQL solves? By having one single entry point, where in RESTful architectures you need to make a request, especially if you want to query multiple collection of dot collections, you need. Uh, Let me begin here, right? Uh, the issue that GraphQL solves is that by having one single entry point, unlike RESTful architectures where you spend unnecessary time making additional requests to query multiple collection of values, and this is aka known as the underfetching problem, whereas the overfetching issue is that the server sends additionally unnecessary extra data that you need to filter out in the browser to show relevant data to the user. So these two issues, GraphQL solved by having one single entry point, okay? And that's one of the advantage of using GraphQL. No more overfetching, no more underfetching. It provides schema and types and speed up the development process. The trade-off is that because this is not a RESTful architecture, which most programmers are quite familiar with that, because it has a couple decades on the industry. Uh, the other is this flexibility adds complexity because the learning curve might be quite steep to do that, and since with Graph we already have proven caching methods. Caching in GraphQL is something that is an advanced topic because they have their own particular way of doing that. Even though I test how can we create or how can I create GraphQL queries using the GraphiQL tool, this built-in browser tool to test GraphQL queries, see what it's doing behind the scenes, or understand what by default GraphQL fetch data, okay, and also how that works behind the scenes. It relies on the HTTP protocol to, by using is the HTTP post request, send data to that GraphQL query, and from there you receive the data that you asked for. I also use tools like Postman or Insomnia to do that, and to really understand how GraphQL really works and how GraphQL service works, I build that from scratch. And previously, looking at things such as the GraphiQL specifications to know where these come from Facebook. It was designed in 2012, and also look at tools that allow us to use GraphQL in front-end framework such as React, like Relay, and more high-end products such as Apollo that allow you to build front and then back-end GraphQL service or apps. And once I started to get my hands dirty on building a GraphiQL server from scratch and see what are the uh, tools that I use and the platform that I rely, particularly here on Node, using Express as a web server and installing the npm package, the GraphQL npm package, and from there create is the schema using the function build schema, where you define all the capability that this GraphQL server has. And then a more realistic example by designing our own e-commerce applications, where in there I define is a couple types, okay, and like this. So in there I define is a couple types that you are most likely to use in e-commerce. Also see that there are several root level operations that you can perform in the GraphQL server, such as query. Okay, that's one of the reasons why we need to define is the type query here is mandatory. And to make our GraphQL server much more scalable, I look at how can we do that, the GraphQL way of doing that, using is GraphQL tools npm package. That what allows us is to, in the case of schema, which is one of the components of GraphQL server, with the schemas, we can is uh, split our files or split our types in multiple files, okay, to help us organize our GraphQL server by features, and also allow us to add more complex data when we need to fetch for some other places, whether it's an API or another service, you name it. And that's what we did with our schema, modularizing our GraphQL server with schema, and using its functions like makes executable, what this accept make executable, where this function accept is and types array, using log file sinks. What it does is to, by giving a particularly glob pattern or a pattern where you can look out for their GraphQL file extensions, load that, and then set that to the makes executable function, which allows us to build the GraphQL type system, okay, or to expose the GraphQL functionality. Side notes: once you use GraphiQL, this not only allow us to make query, but also to see the API and their types. So our GraphQL server now is organized in types and fields rather than endpoints. So once I look at how can we organize our server with schema, okay, and rely on these functions called log file sinks, where this approach is hugely beneficial as long as you define your types correctly and there's no name conflict. Cool. All right. Then I look how can I organize our application uh, uh, with resolvers and understand what resolvers are, which is one of the which is another piece in the GraphiQL service, another component where the answer of this lies on how do we query data. And GraphQL always check if a request operation is valid, and if it is, execute that query. And during that execution, it will call a function resolvers to determine the value of that property. So when you define is a query in the GraphiQL, right, and you send that to the server, it has a proper resolver for each property. And once the server has called all of these resolvers, it wrap it up and send back to the client. This is something great because I also look at how can I create this resolver, okay? And to me at the beginning it was like, what the is this? But as you dive deep into the resolvers, you understand the reason why this exists and also a more realistic example. The anatomy of the resolver, okay? What you have is the parent that receives as the first argument, and this is come from the root value data. The argument is being used when we have parameterized queries, the context to share data across different contexts or different resolvers. An example is if we want to pass authentication data about which user login for all of our resolvers. Info contains some information about the state of our operations. And the cool thing of resolver is that allow us to make asynchronous API calls, right? Now, if, if, if we want to make our application GraphQL server maintainable as much as possible, using this tool like using the GraphQL tools npm package, where we now here create under the same folder structure when you define your features in the same root folder where you set the GraphQL file, your type file. You define also is your resolvers, and here is by abstracting that and putting in a single file. Okay, we can is define is all of our resolvers, and from there perform data layer functions. Okay, so that's what we did here. Okay, and in our example we define is a couple of data layer function access, which what we define is the .model product. We can easily do that, okay? And we send the data back from there. Since we rely on a built-in memory product list to return that, okay? And if we want to look at more interesting and useful use case, like filtering with queries and resolvers, so here we are going to see a more pragmatical and practical use case of resolvers. And this is by defining some of the query is the query that we want and their arguments, again, filtering with queries and resolvers. We not only implement that logic, okay, in our resolvers and also in our data layer functions, we export that. But see the benefits of doing that and a more practical use case on GraphQL. I also queried product by ID. It was pretty straightforward. And then I looked something more interesting uh, that, believe it or not, in GraphQL is not all. So GraphQL is not only for fetching data. You can also need to update existing data or to delete one. So what is the GraphQL way of doing crew operation? And because so far uh, retrieving and reading data in any API is probably the most common basic operation you will ever do. That's one of the reasons GraphQL focus on that and you do it and on doing queries really well. But any real life backend application needs to support all crew operations like create, update, and delete. So mutations allow us to do that. And this is the second type of root level operations once you look at the GraphQL specification, where mutations allow us to change the state of your data. Another root level operations is subscription. Uh, that might be go further or beyond the scope of this course, but it's important to understand that they exist and work, right? Uh, Mutations behave similar as the query. So I look at implementations and also I do that, right? Implementing mutation on the server. And here we're going to implement two mutation and see how it works. So the ability to add a new product and the ability to add new product review. Okay, this is the two mutation that we're going to do. Much like the RESTful architecture, where when you want to define is a crew operation for each one of those letters. For create, you use the HTTP GET, right? For read, for create, you use an HTTP POST request. For read, you use a GET. For update, you use a PUT. And for delete, you use is delete, right? So now with GraphQL, what it's doing is just abstracting that particular layer, okay, and only put you in two operations, two basic operations. It still rely on HTTP protocol, okay, but it puts these two uh, operations. So if you want to read the data, you use queries, okay, and if you want to perform uh, from the CRUD operation, if you want to create, update, or delete your data, you do that through mutations. So it simplifies things quite a little bit, okay? And they do that because they unapologetically are orientated to the front-end engineers when they want to fetch data to show that to the user. The reason is because with this approach, you can reduce waiting load times, so making website uh, faster to load and decrease the interaction time with the user. Okay, so this is the two mutations that I implement here. The add new product and add new product review. Okay, it all starts again with your schema where you define is the mutation here, right? And much like the query with much like parameterized query. Here is a mutation. Okay, you find the add new products and all the necessary things that you need to add a new product with the ID, descriptions, and the price, right? And also the return value. This is a fairly common pattern in APIs, setting the return type as the product in your case to indicate that that data was saved. Then what comes next? So we need to add the resolver to our mutation because mutations are a root level operation, just like queries, and we add that right below the query models, uh, right below the query object, which is also a map or an object that takes the name of our mutations and a resolver function. So this takes the name of our mutations and the resolver function. So what is the body? So what is the body resolver? So what's the body resolver? Yeah, what is the body resolver going to look like? What is the body resolver is going to look like? This is something interesting to me because it's describing is what a mutation is doing. You know, it's describing what a mutation is doing. Exactly. It's describing what a mutation is doing. Mhm. But it's like that. So, on this paragraph, okay, after I define is the mutation on the GraphQL file and ask myself what's coming next, we need to add the resolver to our mutation because mutation are the top level root operations. We add that right below our query object, the resolver, which is a map or an object that takes the name of the mutation and a resolver function. So what the body resolvers uh, what's what's the body resolver is going to look like? So we're going to set some function in our products model. Okay, we didn't have to define this, and this is part of this is one of the this will be a common pattern when doing this GraphQL mutations or query. You know, especially if you rely on GraphQL tools again to make your GraphQL server much more scalable and providing much more features as well. Mhm. Okay, okay. Because after all, that's the whole idea of this. It's providing is much more feature, extend the capability of that GraphQL. You can imagine that as a Megazord or as like Thanos, where you have each one of those infinity stones. Each one of them gives certain abilities, certain capabilities. So it's kind of the same what you're doing here when you elaborate or when you extend your GraphQL server to provide much more service, to provide other capability. All right? And those capability, okay, and those capability, when I look here at the specification of GraphQL.org, okay, and those capability, for example, the type system, can we create a chat with subscript subscription GraphiQL. Building live chat with GraphiQL subscription. Building a real-time chat with GraphiQL subscription. Exactly. So you can even though compare that subscription GraphiQL with subscription GraphiQL with socket.io. For Apollo GLQ subscription versus socket.io. The benefit of the former, it is a box solution that tells you how to do everything, and the benefit of the later is that you get implementing how to do everything. I've used both at scale under the hood. They're basically the same technology, and they're adding any performance difference. If you're using a GKL server, then stick with that. Socket.io is a library that enables real-time bidirectional event-based communication between the browser and the server. GraphiQL subscription, on the other hand, is a concept that allows a client to listen real-time message from the server. So basically, GraphiQL subscription is a specification that defines the policy and rules that allow GraphiQL clients and servers to communicate in real time. And to implement the feature, you can use real-time tools like Socket.io. So according to this answer, okay. So basically, GraphQL subscription is a specification that defines the policy and rules that allow GraphQL clients and servers to communicate in real time and to implement the features with a set of specification that define the policy of that. Building a real-time chat with GraphQL subscription. User online event. Subscribing to new message. Sending message. UI typing indicator. Online users. Trial real apps that use React and GraphQL subscription. Apollo and Azure. But I think they renamed that. I think they renamed that. Real-time chat apps. Mm, 3 February 2022, a year ago. Lighthouse subscription in Azure GraphQL engine can be used to build a full-fledged real-time group chat app on Postgres with React and Apollo. Pro tip, there is no backend code involved, everything is declarative. Azure allows you to build a real-time GraphQL API without writing any backend code. To save bandwidth, we use subscription to listen for message events, then run a query to fetch only the new message. Every 2 seconds, our frontend runs a user online mutations to populate an online user list. Our frontend runs a user online mutations to populate an online user list. Exactly. A user typing mutation is run whenever we type few characters, and subscription is used to fetch the last typing user. A user typing mutation is run whenever we type few characters, and a subscription is used to fetch the last typing user. Okay. 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 So, uh, this is something interesting. This is something interesting. What you can do with GraphQL, and the reason why you need to dedicate time to pondering, to think about the ideas, to understand and where you can apply it. Because at the end of the day, most of your clients will ask you is that, hey, I would like you to do this, blah, 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 blah. And you say, hey, we can use this for this particular use case, and this will be the benefits. Blah, blah, blah. It will reduce a lot of load, waiting load time on users, meaning that we are going to have much more user retention, or it's more likely that we have more user retention and user convention. That's what happens. That's what it is, right? By reducing the waiting load time using GraphQL, we will have is much more user retention and hopefully user conversion. So that's what you're doing. So you're expanding into your skill set, okay? Uh, to this type of things, particularly the technology, the marketing, the sales, and you understand all of this. That's what a senior developer or a tech lead most likely are capable of doing. Okay, all right, good. And after I saw this mutation, okay, this is another row level type operations in GraphQL service. That's one of the reasons why when you define is mutation, you do that on the resolver functions. especially if you want to create scalable GraphQL servers relying on GraphQL tools npm package. So in there is in the resolvers you define is the mutation, which is an app or an object where it takes the name of the mutation and the resolver function. And the body of these resolver functions uh, is some function that you will define in your data layer access, in our case, the product dot model, and we're going to put all the logic in there in our data access layer to keep our resolvers as thin and small as possible. So we want these resolvers to be independent. Another important characteristic is we want this resolver, so we want to keep our resolver thin and small as possible. We want these resolvers be independent whichever model we choose to use. Mm-hmm. Yeah, we want these resolvers be independent whichever model we choose to use. Exactly. So we want these resolvers be independent whichever model. Okay. We want this model to be independent. Okay. We want these resolvers be independent whichever model we choose to use. Okay. Exactly. So we want these resolvers to be independent whichever model we choose to use, whatever database they're using, and any other implementation detail. So we want this model essentially is looking at the high cohesion, high cohesion, high cohesion, and low coupling, right? Knowledge Bureau, right? High cohesion and low coupling. So high cohesion means the degree of this model. It is the number of responsibility that this model has. Okay. So the higher the cohesion, the less responsibility that this model will have. And low coupling means is the dependency that this model have with others. So a lower cohesion, the better. Mhm. I look also to high cohesion, high cohesion. Um, mm, 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 mm. Where did I see this? High cohesion in software. Mm-hmm. No, but it was from a website. Mm, is a measure how strongly related and focused the various responsibilities of a software unit are. Coupling, need for abstraction, poorly selected boundaries, many monolithics, God objects, clean, high cohesion, and low coupling. In low cohesion, exactly, each one of those different models are in different, so the different responsibility are in different models, and they relate each other. High cohesion and high coupling. Low cohesion and high coupling is a worse situation to be. A code smell that emerged from this situation is what we call got off. Mm, but again, to the degree to which elements inside of a model belong together. That's cohesion. In one sense, is the measure of the strength of relationship between the methods and the data on the class in some unifying purpose or concept served by that class. In another sense, is the measure of the strength of relationship between the class methods and data themselves. Cohesion is an ordinary type of measurement and it is usually described as high cohesion or low cohesion. Model with high cohesion is said to be preferable because high cohesion is associated with the several desirable traits of software, including robustness, reliability, reusability, and understandability. In contrast, low cohesion is associated with undesirable traits such as being difficult to maintain, test, reuse, or even understand. Cohesion is often constrained with coupling, a different concept. High cohesion often correlates with loose coupling, and vice versa. So cohesion is increases the functionality embedding in a class. Uh, it's not only is the relationship on which the methods are relevant to that class or to that model. To that model is the relationship between the methods and the data of a class in a unified purpose. The less responsibility that a model has, the better. Okay? And coupling is the degree or is the number of dependency this model has. So, a less dependency it has, the better. It's much more maintainable, reusable, robust, and understandable. Okay, okay. So this is one of the explanation of why here are we abstracting is all the data access layer in a function that we define in the data access layer, the product model here, because we want to keep our resolver thin and small as possible and be independent to whichever model we want to choose to use and whatever database or any other implementation details. Okay, we want these models be independent to whoever, to whichever model we choose to use, whatever database we're using, or any other implementation detail. And that's the core of this. So we're going to pass is the argument it meets. So this function will return the prototypes that was added. A new product, in this case here, what we define inside of our resolver function is inside of our resolver body, the functions that we're going to the function from the access data layer where we're going to put all the logic to do this capability, add a new product, okay, and we return is that new product that we create, okay, and in our GraphQL mutation, it looks something like this, and you will get is this, the new product. So add a new product is by ID and review, because this is where we define what will be the property we want from that. Okay, we want is the ID and the review. So exercise, add a new product review, and we're going to practice how to write mutation and dive deep how mutations are executed and how to execute many mutations all at once. So what I'm gonna do here is looking at this. All right. Oh, come on. Okay. Anyways, well, I'm going to leave this video like this, and I will see you in the next video. Take care. Bye.